There's a couple of things I'd like to say before we turn it over to the rest of the program. First of all, last night I found myself in the position of trying to get a rise out of certain parts of the audience. And I realized that this is an infallible sign that you've talked too long, or that you haven't got anything to say. So I'm going to say one thing that I should have said last night that probably would have been much more useful than all of what I did say. And that is the difference between the PCT view of behavior and other views. In the PCT view, we take the viewpoint of the behaving organism. And in most other sciences, you take the view of the observer of behavior, of the outside observer of someone else's behavior. Now this means that you get a very different picture of what's happening. From the outside, what you see is the back of the glass the person is drinking from, and the bottom of the glass as he tilts it up. What you don't see is how it feels to hold the glass, and the fact that the water's wet, and the fact that your thirst is being coped with. None of this is visible from outside an organism. And the behaviorists decided that only that which is visible from outside the organism is valid science. Whereas in PCT, we say that which is only visible from outside the organism is probably wrong and gives you a misleading view of what's going on. Now, to understand what's going on inside the organism, if it's not going to be just introspection, which had its run, you need a model. You need some picture of the organization inside the organism. Something based on principles, something you can demonstrate by itself in the abstract, and something that you can apply to make predictions about behavior. So this is how the interior view gets connected to the exterior view. The interior view says, here is how the world looks to the organism. It's controlling its perceptions by means of its actions. But there's a model that explains how the perceptions work, what the connection is between the perception at a given level and the action that's produced, what the action has to do with the perception via the outside loop, and this model can actually be run on a computer. So now, if you say, it seems to me that it works this way, you come up with this idea and you scribble a diagram on the board, you're now required, this is what the engineers in the group have to do for the rest of the group, you're now required to reduce this model to something that will actually run. In other words, to prove that an organization made of blocks and arrows and more blocks and more arrows and all over the place, environment over here and stuff like this, that'll do something. You scribble this. It's like a doodle while you're thinking about the subject, the behavior you're trying to describe. You make this doodle on paper and you sort of sketch in relationships. But then the question is, if I had to build one of these things according to that specification, would it do anything like what I thought it would do? Would it do anything like the behavior that I purportedly am describing with this model? That's where the discipline of modeling comes in, and that's what keeps the introspection honest. Because if the model won't run, then your conception of what's going on is incoherent. That's what it amounts to. So that's what saves the introspective, the internal view, from being mere introspection. Okay, that was one of the things I wanted to say. Now, along those same lines, when you look at another person's behavior, you're looking at it from completely the wrong perspective to understand it, aren't you? You're only looking at the exterior surface of what's going on. You can't see what that person is controlling. You can only see the actions by which he's controlling what matters to him. And that means that you need a systematic way of discovering what he's controlling. That's one of the basic methodological underpinnings of control theory, the methodology, which we call a test for the controlled variable. If something is controlled, you can, here, there's an eraser. Is that a controlled variable for any entity, visible or invisible? Well, I can test it. No, it stayed where I put it. See, I can put this eraser anywhere, and nothing will move it back where it was. So it's not controlled. But if I move other things, yeah, something shows up and puts it back the way it was. Well, so I get a suspicion. Maybe it is a controlled variable. I'll try a different. Oh, yeah, very good. That way?
That's fine.
This way?
No, right down.
Okay. All right. So you think of all the different ways you can disturb it, this so-called controlled variable.
Hey, that's my paper, you have to cut it.
Okay.
Well, watch
He's not
this, Bill, see
controlling.
what happens here.
He's not controlling. Oh, yeah, if I put it, oh, yes, you can get fooled. Here. Okay. He wants that space to write on. So I disturbed something he was controlling. So I might have thought he was controlling this, but then if I wiggle it around, I find it's not. All right, so the test for the controlled variable is pretty simple and obvious, but it's very powerful. It enables you to test your idea of what another person is controlling. You just nudge it a little bit and see if he pushes back. And that's basically what a control system does. Once you've proven that he is controlling something, you can then try to explain how or why. But basically, the first thing you have to do is verify that something is under control. If a kid is making a, suppose a kid in class is making a lot of fuss, and you say to yourself, oh, he's just asking for attention. What you're proposing is that there's a controlled variable there. He wants to perceive people attending to him. So suppose you said, oh, did you want something? Are you okay? And he stops fussing. What do you know? He was trying to get attention. Then you can ask yourself, well, okay, what's he need attention for? Attention about what? And eventually you can discover the controlled variables that this kid is trying to keep in shape for himself by means of all this behavior that's so annoying to other people. And maybe you can teach him other ways. This is what Ed's social awareness classes, or whatever he calls them, are. Teaching kids other ways to achieve what they want that don't impinge on other people so badly. Kids always like to impinge a little bit. That's the interaction. But anyway, if you apply control theory systematically using the basic principles, the proper point of view is the view from inside the organism. The model has to coherently explain what goes on both from the inside and the outside, and you have to test your hypotheses about what's under control in a systematic way. And once you get those principles down, the whole thing begins to take shape all by itself. That's all I wanted to say about that. The other thing was about cognitive dissonance. Cognitive dissonance is a phenomenon, but I would like to see it reduced to some definitions so that you can tell when there is cognitive dissonance and when there is not. I would like to see a model that explains how it is that cognitive dissonance can produce any effect whatsoever on anything. And if it does produce an effect, why it produces the effect it does, rather than some other effect. And if people behave as a result of it, what is the effect of the behavior on the cognitive dissonance? If you can lay out this as a coherent picture, then you've got a theory and you've got a testable model. I suspect it will turn out to be PCT in the end. So there's no necessary clash between this psychological theory, that psychological theory, and PCT. But to find out if there is or not, you have to be very careful about defining what you're talking about, drawing the parallels, and this goes with that, this goes with that, and seeing whether the other theory offers the same kind of explanation control theory does. If it does, if it offers identically the same explanation, then it is control theory, or vice versa. Control theory is cognitive dissonance theory. I don't really care. The names don't matter. But the relationships are what matter, not what you call them. If you understand the relationships, then you have a good theory, and you can express it in a number of different ways. So that was the answer. I spent a lot of time thinking about what I should have said. And that's what I should have said. So that finishes me off for this morning, and the next person up is Rick Markin.
Oh, you're not allowing any dialogue?
Biology text that explained the reinforcement of the animals and so on, and it wasn't until long afterwards that I went back to read Skinner himself and discovered what all these textbooks had left out, that it wouldn't work if the animal wasn't starved to 80% of its weight before you started the experiment. That had never been mentioned by anybody. It was a hidden fact, and yet it was essential to the whole thing.
Oh yeah, and along the same lines, Skinner makes a whole lot out of the schedule of reinforcement. The rat presses the lever. Here's the lever. The lever operates an apparatus, and out of the apparatus there comes little pellets that drop into the food dish. And the schedule of reinforcement is the way in which the lever causes pellets to appear. And in here you can put all kinds of programs saying, every 10th press gets a pellet, or every 10th plus or minus 6 presses at random gets a pellet, or every time you press it, only after a certain interval do you get a pellet. So you can put all kinds of programs in here. But what he missed was, and then he said, and it's the reinforcements that act on the animal to increase the probability that it will produce this response. So his whole theory was a cause-effect theory running this way. And what he forgot about, was out there in the environment, is this obvious cause-effect link running that way. The one thing you can clearly see is that the behavior is causing the reinforcements. The reinforcements are not causing the behavior. I mean, that's hypothetical. Hypothetically, the reinforcements are having some sort of effect on the animal. It's influencing its behavior. But what we can see is that the behavior is rigidly causing the reinforcements by a perfectly understandable law. Yet he ignored that part. Now, the biggest problem, of course, is that here you have a behavior and here you have a consequence, okay? And there are two relationships involved here, not one. One of them is the behavior causes the consequence according to one sort of functional relationship. And the other one is the consequence causes the behavior by a different functional relationship. So when you think in terms of a complete model of the situation, including what's going on outside as well as what's going on inside, you realize you've got two functions and two unknowns. You don't have C as a function of B or B as a function of C. You have two different functions connecting B and C, and B and C at all times have to satisfy both functions. Two functions, two equations. Which means B and C are both dependent variables. Neither one is an independent variable. If anybody had thought about this at all, they would have realized that. If you put an animal in a Skinner box with a certain schedule of reinforcement, there is nothing to say that that animal will ever get reinforced or that it will ever behave. There's nothing in the theory to say that. You have to say, if reinforcements appear, or if it behaves, then it will get reinforced. And the reinforcement will react upon the animal and the behavior and the reinforcement and so on. But what's to start that behavior before there's any reinforcement? The problem is they've got two equations and two unknowns, and they're trying to specify only one variable. Impossible. It's an indeterminate model.
It's a very, very important point. And also, if you think, in terms of what we were talking about last night, if you ignore the obvious thing in the environment out here and talk about reinforcement going in and behavior coming out, we're back to the poke it and see what it does approach again.
Yeah.
Pen goes in, the animal withdraws. Your hand withdraws. The food goes in, the animal behaves more. That one of the interesting, I think it's almost an ironic twist in behaviorism, is that there was a big emphasis on talking about observable behavior, on what is observable. And what was sitting, as you say, out there to be observed the whole time, but it wasn't observed, is something completely different from what they described. And had they focused on what happens out here with the lever and the food, they would have realized that as the schedule changes, the number of bar presses goes up and the amount of food that comes out stays the same. They would have seen evidence of a control variable right there in the food dish. But they weren't looking for that. They were looking for something that went into the animal to make it behave. Right in front of them all the time was a clearly identified control variable.
Well, part of the problem is trying to think in loops. It doesn't come naturally to think in terms of closed loops. If you think of rewarding a child for good behavior, you get the feeling that the child responded to the reward, if you know if it works, that it responded to the reward by behaving better, so that by using rewards and disincentives, you can manipulate the behavior. But what you forget is that that's only this part of the loop. You're forgetting about this part of the loop. Look at it from inside the child. By acting in a certain way in this particular environment with its peculiar properties, you can cause the things you want to appear or to happen. You have control. So if the teacher is operating according to a fixed rule, that teacher might as well be a machine, like this. If you see the child behaving in a certain way, then you produce the reward. So you're acting like the apparatus, like the schedule of reinforcement. And Skinner emphasized, you must do this consistently. You must not do this creatively. You must act like a machine, like a passive part of the environment. So that if the animal wants the reward, it can do the thing that makes you behave in the way that gives it the reward. So what looks to you from outside the organism like controlling its behavior by giving rewards looks from the inside of the organism like acting in a certain way to cause the rewards to appear. They're both correct, but neither view is complete. What's really happening is you have a closed circle of relationships. And you always have to remember that you always stand in that loop for someone else. Anybody else? And I'll sit down.